Alright, so we're covering a new lesson today. Basically, it's finding the derivative, but we want to use a shortcut today. Alright, so we're going to use a shortcut. So this is on page 134. So let's open up to page 134. Make sure you have your notes. This is a lesson on 2.2, basic differentiation. Rules. Alright, so there are many rules that we do need to go over in this class by the end of the school year. But for now, today, we're going to learn a total of 5 basic rules. Alright, so do you guys remember your formulas from last week? Do you guys remember how to find the derivative or tangent slope using the limit formula? Anybody remember the formula? Limit h goes to 0, f of x plus h minus f of x all over h. Okay, good. So we don't need to use that today. That was a very long process, but we don't need to use that. Today, we will use some shortcuts. So here's number 1 rule. Number 1 rule is on page 137. It says theorem 2.2. It says the constant rule. Alright, I hope you guys know that constant is just any number. Any number is constant, like 7, 10, 123. Whenever you take the derivative of a constant value, and here's a notation, d of dx, c stands for constant, it is 0. Sometimes, instead of this notation, you're going to find notations like f prime, or you might see a notation like y prime, or you might see a notation of dy over dx. All of these things just means what? Derivative. So any notations that you might see, don't get confused. They're just giving you different ways to write derivative notation. Alright, now when you look at this, you need to know how to read this notation. This top D stands for derivative of C, constant, derivative of constant C, respect to derivative of x variables. Now, the calculus that we're learning in this class is called single variable calculus because we only, like most of our questions are x variables. Have you noticed that? F of x is equal to, so we're only taking the derivative of x variables. But when you take higher level math, they do have multivariable calculus. So instead of just having x variable, you have multiple variables. We will study like a couple of variables in this class, but we're not going to have many variables, okay? Maximum we'll have 2. Okay, so there it is. So let me show you an example of this. So it's very simple. Let's say derivative of 11 is just 0. Or if 11 prime, right? 11 prime means derivative is also same thing, 0. Do you think you can memorize that? That's pretty easy. All right, I think so. All right, number 2 rule is on page 135. It says theorem 2.3. This is called the power rule. It's called the power rule because you're using the power. You want to put them into like a polynomial format. You want to try to put them into a polynomial format. So for example, it should look like f of x is equal to ax squared plus bx plus c and blah, 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 like that, okay? So when you put them into this type of format, then we can use this power rule. All right, what's the power rule? Power rule says derivative of x to the nth power. You see that? X to any nth power. The rule says you bring down the exponent to the front, which is n. X to the power of, since you bring one of the power to the front, you lose one. So n minus 1. So this is your rule. Alright, so let me show you an example of this. It's pretty easy, but I'll give you time to copy this. Go ahead and copy that. Alright, so here's an example. Let's say we have f of x is equal to x to the third power. We want to find the derivative. Alright, you want to find the derivative. Alright, let's try to use this rule. There is a power right here. You see it? You see the power? So if I use this rule, this is f prime of x, which is your derivative. So how do I use the rule? What do you do with that 3? Put it in the front. X to the power of? 2. Yeah, 3 minus 1, which is 2. And this is your derivative. Alright, what is another word for derivative? Remember I said derivative is also same thing as change in rate, which is same thing as tangent slope, which is a slope formula. Remember that? So remember when we had to find the derivative and find the equation of the tangent line at a point? Remember that's what we worked on last week? What's the long process? Do you remember the long process of doing this? Like now it's short, really short, but how do we solve this before? Wasn't it limit h goes to 0, f of x plus h minus f of x all over h? What was it? Limit h goes to 0. What is f of x plus h? Can you help me with that? What would that be in this case? X plus h to the third power minus x to the third all over h. And what do you do with that part right here? Do you remember? You FOIL and multiply everything out and then simplify everything, and eventually you need to cancel out the h at the end. That's how you know you did it right or wrong, right? We have to take about half a page to do this. Remember that? Yeah. How many steps or how many pages do we need, or how much of a space do we need to do this? Like it's very small, right? Isn't it? Very short now. Okay. Out of number 2, they want you to memorize something. At the bottom of page 134, everyone go to the bottom of page 134. They want you to memorize d of dx, x variable, is just, what does it say? 1. This is 1. You want me to show you why? Okay, so if you have x, what power do you have for x? 1, isn't it? So what do you do with that power? You bring it down, so 1 times x to the power of, what do you do with that power now? 1 minus 1, you subtract 1, what is 1 minus 1? What is x to the 0 power? What is x to the 0, anything to the 0 power? 1, so 1 times 1 is 1, so therefore this is 1. We don't want you to do this. You understand that? It's easier to just memorize that x is equal to 1. Can we do that?
Yes.
All right. So how many of you guys feel like you memorized number 1 and number 2 rule already? Okay, very nice. So let's do some examples, okay, where we can use those things. All right, let's find example 7 on page 138. Everyone turn to page 138 and find example 7. All right, I'm looking at part A. Okay, again, they can use any notation. It could be f of x, g of x, s of x, whatever, okay? It says f of x is equal to x to the power of 3 minus 4x plus 5. You want to find the derivative. All right, I want you to think about this. Go ahead and copy it. I want you to think about it in your head. This is so easy, you can just kind of come up with the answer in your head. Think about it. I'll give you about 30 seconds to think. Don't tell me. All right, I gave you a few seconds to think about this. Look, if I cover this, there's a constant 5. What's the derivative of constant 5? 0. Here, look, there's x. If I cover the 4, there's x. What's the derivative of 4? X. 1, so negative 4 times 1, which is negative 4, right? And there's x to the third. What's the derivative of x to the third? 3x squared. That's it. So your derivative is f prime of x is equal to 3x squared minus 4 plus 0, but we're not going to put any plus 0, and this is your derivative. Do you think it's possible to find the equation of tangent line now? Do you guys remember how to find the equation of tangent line from last week? What if I gave you a point 1, comma 1? How would you find the equation of a tangent line? Do you guys remember? You have to plug in x to find slope. What is the slope? Tangent slope, isn't it? 3 times 1 squared minus 4, which is negative 1. That's your slope. And how do you find the equation of the tangent line? Point slope, remember that? Y minus y1, mx minus x1. They're going to ask you to do all this stuff again, but with the shortcut. Does that make sense? All right, now, it will be easy to see it in this form. Do you see this polynomial format? It is really easy to take the derivative if you could put them into that form. It doesn't mean that everything is in this form. So let me give you an example of where you need to rearrange your function or manipulate your function so that you can make it into polynomial format, okay? So look, if I gave you f of x is equal to square root of x to the third power, this is not in one of these forms. But you need to know that, I don't know if you guys know this, how do you rewrite square root of x? Anybody know how to rewrite square root of x? What's square root of x? This is x to the power of 1/2. If you don't know this, you need to know this, okay? Square root of x is same thing as x to the power of 1/2. So I need to change this format. This is not a good format. I want to make it into one of those formats right there. So do you have an idea how to change this format to one of these things? It is f of x. I want to rewrite this as, f of x is equal to x to the power of 3 over 2. That is correct. Why is it important to learn how to write it in this format? Now I can use the power rule, because this one has a power now. Do you see it? I can use a power rule. Alright, so how do we use the power rule? F prime of x is equal to 3 over 2, you just bring it down. X to the power of 1/2, because it's 3 over 2 minus 1, which is 2 over 2, so this is 1/2. Alright, you don't want to leave your answer like this. You want to rewrite this over again. So how would you rewrite this so that we are familiar with our function? So how would you rewrite x to the 1/2 power? Square root of x. There it is. Aren't you familiar with that format? Yeah. So we started with that, and we changed it to power, okay, using this idea. And then after you take the derivative, you change it back. Okay, how many of you guys follow what I just did with the square root? Okay, this isn't the only format that you need to change. You also need to know this. X to the negative 1 power. What is x to the negative 1 power? 1 over x. So if I have 1 over x, then I can also change it to x to the negative 1. So for this one, you go to example 6 on the top. It says y is equal to 5 over 2 x to the power of 3. You see it? This is part A. Again, you don't have to have f of x. Y is fine. I want you to find the derivative again. Find the derivative. This is not in a good format. I need to change this form. So anybody have an idea how to change this to the format that we wanted? So you want to rewrite this as y is equal to 5 over 2 x to the power of negative 3. If you have it in the denominator, right here, do you see it? You can bring it to the top as negative exponent. Here's the denominator, you can bring it to the top as a negative exponent. Okay, how many of you guys understood what I just did? Alright, so half. Why is it important to make it into this format again? I can use a power rule. Alright, so go ahead and use a power rule. So what is y prime equal to? Negative 15 over 2 x to the power of negative 4. Very good. Minus 1 will give you negative 4. Again, you don't want to leave your answer like this. You want to rewrite this to the original form. So you want to write it as original form. So how do I rewrite this as your original form? Y prime is equal to, what do you think, guys? 15. Negative 15 over 2x to the 4th power. And there it is. Was that pretty easy to follow? Okay, I hope so. Alright, so we learned 3 rules. Actually 2 and 1 you just have to memorize. Remember that, right? So we know the constant rule. I hope you know it. We know the power rule. I hope you guys know that. And we know that derivative of x is equal to 1. We know that. Okay. All right, let's do an example of where you need to kind of rearrange things from your homework, okay? So let's turn to page 143. Page 143. Find number 44. All right, number 44, we have h of x is equal to 4x to the third power plus 2x plus 5 all over x. All right, this is not the form that we want this in. This is just too complicated. We want to make it into a polynomial format. I want you to think about it for 30 seconds and tell me if you can rearrange this or manipulate this so that you can have it as one of those forms that we've been studying. All right, what do you think, guys? Anybody have an idea what we need to do for this one? You need to rewrite this. Anybody have an idea?
Would you remove the x from the bottom and make it x to the power negative?
Yeah, so you can do that. Okay, he says you can move this to the top. You can multiply by x to the negative 1 and distribute all of them, which is fine. You can do that. Or you can actually just separate them and which would be the same thing. All right, so this is 4x to the third over x plus 2x over x plus 5 over x. It's the same thing. So what happens over here? X cancels out, so this is 4x to the power of 2 plus, what happens over here? 2 plus, how do you rewrite this? 5x to the power of negative 1. And that's what he was telling us to do. If you multiply by x to the negative 1, basically that's what you get. Do you see it? 5 times x to the negative 1? You see it? Okay. This is a form that we want. Why do you want to rewrite it into this form? Isn't it easy now? What's the derivative of this? Help me out. What's the derivative of the first one? Not so easy. 8. 8x. What's the derivative of 2? 0. I'm not going to put 0. What's the derivative of that? Negative 5x to the power of negative 2. All right, again, this is correct, but usually you're not going to see your answer in that form. They're going to rearrange this again to your original format, fractional format. So how do I rearrange this? Isn't this the same thing as 8x over 1 minus 5 over x squared? Does everyone see what I just did? How do I combine these two fractions? What do I need to have? Common denominator. So you multiply by x squared and x squared. So this is 8x to the third over x squared minus 5 over x squared. Can I combine these two fractions now?
Yes.
So h prime of x is equal to 8x to the third minus 5 over x squared is your derivative. All right. Look at this. Remember I told you that this one is correct? Remember I told you that this is correct? We have to rearrange, and this is also correct, but it looks differently. As a calculus student, you need to know that these two are same. How many of you guys understand that? And you need to know how to convert this form to that form, and this form to this form, vice versa. Because sometimes your answer will be in this format, sometimes your answer will be in that format. And you need to see the connection between those. So learn how to, find those things in a different format. All right, so we feel somewhat comfortable with these things. Once you feel comfortable, we should know how to find the equation of the tangent line, right? So take a look at number 33. Find number 33, same page, 33. Read the direction. What does it say in number 33? You need to find the slope. There's that keyword slope. Whenever you see like slope, tangent line, slope, you think of what? Derivative. Derivative is your slope. So whenever you see keywords like slope or tangent line, you think of derivative. So here's number 33, which is y is equal to 2x to the fourth minus 3, 1 comma negative 1. All right, now finding the derivative is very easy now. So can you find the derivative? Go ahead and find the derivative. What is your derivative? So y prime is equal to 8x to the power of 3. This is your derivative. Look at how easy that was. Okay, we're not quite done. We need to find the slope, m. Do you remember how to find m slope?
Yes.
What do you do?
Plug it in.
Plug it in. This one. You just have to plug it into. This is your slope formula. Remember that? We talked about having a slope formula. We plug it into the slope formula. So what is it? 8 times 1 to the third power, which is 8, is your slope. Okay, well, that's it for this problem. But what if I ask you an additional question? Can you find the equation of a tangent line? How do you find the equation of a tangent line? Do you remember from last week? Which is y minus y1 is equal to m times x minus x1. So help me. What is it? Y minus negative 1, which is plus 1, is equal to 8 times x minus 1. And then I asked you to simplify this, right? You can leave it like this or simplify. You remember last week we took the whole page to do this, or half a page to do that? Today we're taking about 2 to 3 lines and that's it. And we're done. Okay? Of course, we're not going to just stop with just 2 formulas today. We need to add 3 more. So we have a total of 5 formulas we need to know. Alright? So the next formula, number 3, is on page 139. Let's turn to page 139. Alright, this is number 3. Rule number 3. This is a derivative of sine. It says derivative of sine and cosine. Number 3, derivative of sine, d of dx, sine x. What does it say? What's the derivative of sine? Cosine x. Derivative of sine is cosine x. Number 4, rule number 4, this is derivative of cosine. Alright, go to your book. What's the derivative of cosine? Derivative of cosine x is negative sine x. That's number 4. I want you to study number 3 and 4. See if you can memorize this in about 10 seconds. I think they're pretty easy, right? Sine derivative is just cosine. Only thing you have to remember is cosine derivative is just opposite sign, right? Negative sign. Alright, so do you remember your constant rule? That's easy, right? Do you remember your power rule formula? That's easy. Now, do you know your number 3 sine rule? Yeah, that's easy. And cosine rule. And that's easy. And we have a last one. Number 5 for today. Today is the last one, but we actually have a lot. Alright, number 5. This is on page 140. Number 5 is the derivative of the natural exponent. Alright, derivative of the natural exponent says derivative of e to the x is, what does it say? E to the x. Alright. So we have 5 formulas that we need to use. Let's see if we can find an example from your homework page where they use all of them. Okay? Alright, so let's turn it over to page 143, number 24. Y is equal to 3 over 4 e to the x plus 2 cosine x. I'll give you time to copy it. Alright, so I want you to think about it. Don't solve it yet. I want you to just think about it again. A lot of it you can do it in your head. Mental math. Alright, here's a cosine. Do you know the derivative of cosine? Negative sine x. So 2 times negative sine x is just negative 2 sine x. Does that make sense? Here's e to the x. What's the derivative of e to the x? E to the x. So there's 3/4, so your answer is 3/4 e to the x. You see it? So y prime is 3/4 e to the x plus 2 times negative sine x. Y prime is 3 over 4 e to the x minus 2 sine x because you multiply negative and 2. You see it? And that will be your derivative. Look at how simple they are. Now, I'm not going to show you the proof behind it. We're just going to believe that these are all true. Alright? But there are proofs in your example. It says, this is why they're equal to each other. Alright. Now, of course, we need to apply to this. Like, we need to apply this information to something. Like, why do we use derivative? What do we use derivative for? Like, I mean, why is this so useful to me? Okay? So, let's go back. Derivative, we think of it as a slope. Right? Isn't that what we said? Derivative is the same thing as a slope. We also said that derivative is like a slope, and slope is the same thing as rate of change. It's a rate of change. Rate of change in our respect, like I know there are many types of rate of change, but I think the easiest one for us is driving. Like 50 miles per hour. That's a rate of change. You understand that, guys? 50 miles per hour is a rate of change. Like miles, this is miles over time, hour. Does that make sense? So rate of change is slope. Slope is rate of change. So derivative is same thing as rate of change. But what do we call this in real life? We don't call it rate of change. We call it speed. Don't you? So speed is rate of change. But if you want to sound fancy, if you're taking physics, anybody taking physics? They don't call it a speed. They call it a fancy name of velocity. Don't they? Don't they call it velocity? Doesn't velocity tell you which direction you're moving? Positive direction and negative directions and all that stuff to be fancy. So derivative is velocity. So we're going to use derivative to figure out how fast things are moving. Does that make sense? So we're going to apply derivative to speed. All right, so let me show you how to do that. So for that one, we turn to page 141. Page 141. Okay, we're going to see the difference between the average rate of change versus instantaneous speed. All right, so there's a slight difference between average rate of change and instantaneous. Instant, for an instant, right? So average rate of change, we're going to call it average velocity. All right, so sometimes they're going to call it average rate of change, but to make me, like, I don't want to call it average rate of change all the time. So can I just call it average velocity? Is that okay, guys? Because remember I said rate of change is like velocity? All right, so instantaneous speed will be velocity. Okay, so this is average velocity, and this will be the actual velocity at that moment. All right, in terms of formula, average velocity, which is average rate, is f of b minus f of a over b minus a. Usually this is in terms of time. All right, so for average, we need to use this formula. Okay, this is your formula that you use. For instantaneous velocity, we're just going to call it velocity, is f prime of x, which is just your derivative. Your derivative will give you your instantaneous velocity. Let me show you how to use it. Alright, sometimes I get too excited and I go too fast, and then I don't know how far behind you are. Okay, anybody need more time with this? Alright, look at example 10 from your book. Example 10, same page, 141. Read it to yourself. I'm not going to write down the whole thing. You know, I mean, I'm too lazy to write the whole thing. Okay, but read it to yourself. Alright, so basically, you have a ball. You're up at a height of 100 feet, height, and then we're going to drop it. And this is a function they're giving you. S is equal to negative 16t squared plus 100. Anybody understand why they have negative 16 here? Anybody know? If you're taking physics, you should know. Did you know that in Earth's gravity, the gravity pull is how fast? Do you know? Yeah.
Negative 32 feet per second.
Yeah, that's negative 32 feet per second squared. That's your acceleration. But velocity is negative 16. How much is it in meters? 9.8, negative 9.8. You're supposed to know those things. But I'm teaching you that negative 16 is in terms of feet, negative 9.8 is in terms of meters. Okay, that's just different units. You understand? So this problem is feet, and 100 is how high you're at. Okay? So remember I told you to visualize your problem? Basically, this is what's going on. Here's a cliff. You're standing on the cliff. You're holding this ball, and you're dropping it. Right? And you're dropping it to the ground, whatever. Time equal to 0, that means at that moment, in the beginning, we're holding on to this ball. You're holding on to the ball in your hand. Does that make sense? And then t equal to 1 second later, your ball might be down here. Do you understand that? 2 seconds later, your ball is down here. But if you're taking physics, you also need to know that the speed of this ball is increasing as you fall down. Did you know that? Okay. So those things you should all know. So those are the things that you should picture in your head. All right. Part A says you want to find the average rate from 1 to 2. I'm not going to do the whole thing, okay? So that means you want to find the average. Do you see this? This is time. From 1 second to 2 seconds, you just want to find the average speed between those two times. What's the average between 1 second and 2 seconds? So how do I find the average? So look at this right here. Average velocity is s of, s of b minus s of a over b minus a. Why am I using letter s? It says f, but why am I using letter s? Because it's a function. It's whatever this function is. If it is f, then you put f of b, f of a. If this is s, then s of b, s of a. If this is k, then put k of b minus k of a. Are we clear? All right, so this is a and b. So let's plug it in. So what is s of b? You need to help me with this, okay? So what is s of b? Isn't this, in this case, this is s of 2 minus s of 1 over 2 minus 1? How do I find s of 2? Plug it in. So this is negative 16, 2 squared plus 100 minus negative 16, 1 squared plus 100 all over 2 minus 1. Okay, someone help me out with this. Can you calculate this value? What is that value? Anybody know negative 16 times 4 plus 100? Someone. 36 minus, someone calculate negative 16 times 1, so negative 16 plus 100. 84 over 1. What is 36 minus 84 over 1? This is negative 48 feet per second. All right, so what is this representing? What is negative 48 feet per second representing? That's the average speed between 1 and 2. And why is it negative 48 feet per second? Because your object is falling down. You see that? If your object is a rocket, if it is taking off, then it will be positive. It will work out to be positive. Does that make sense, guys? Okay. Now, for me, average doesn't really help me too much. I would rather know, as a scientist, what would you rather find? Yeah, I'd rather find the actual speed at 1 second. I want to know exactly how fast you're traveling at 1 second. And then I want to know how fast you're traveling at 2 seconds. And are they traveling at a different speed, at a different time? And I want to know exactly how fast you're traveling and how much faster at a different time. Don't you rather know those things as a scientist? If you want to make sure that one person is going to make it to Earth on time, don't you want to know exact time at a different time? Right? So, part B, I want to know the instant velocity at t is equal to 1 second. I want to know the instant velocity at time equal to 1 second. How do I do that? For instantaneous, what formula do I use? Derivative. So what's my derivative? How do I find the derivative of this? So it is s prime is equal to, why is it s prime? Isn't that s function prime derivative? So s prime is equal to negative 32, what?
X.
It's t, isn't it just t, not x, right? Negative 32t, it's just variables, right? Plus 0, I don't need to put, so this is your formula. This is your speed formula. So what number do I need to plug into this t? 1. So it's negative 32 times 1, which is negative 32 feet per second. So at 1 second, exactly at 1 second, your ball is traveling at negative 32 feet per second. What if I want to figure out t is equal to 2? What do I do then? Negative 32 times 2, which is negative 64 feet per second, is how fast this ball is traveling at 2 seconds. And you can tell the difference between average. Do you see the average? 1 second, 2 seconds. Do you see that they're all different? Right? And it makes sense to have an average between those two, doesn't it? Average should be between those. Right? But these are instantaneous. Alright, how many of you guys follow what I just did with this? That's what we're going to do in this class. And that's what you're going to solve in your AP exams. They're going to give you different parts and you need to figure out different speed at a different time. Go to number 95. Find number 95. On page 145. That's part of your homework. Read it. They don't give you the formula. You're supposed to come up with it. Anybody have an idea what your formula is for number 95? Anybody have an idea? Yes. S is equal to negative 16t squared plus 1,362. There it is. Okay, why are we missing V naught? Can someone tell me why we're missing V naught? Because I'm holding on to the ball and I'm just letting it go. But if I throw the ball, let's say if I throw the ball higher, then do you have a V naught? You would. Okay, sometimes you throw the ball up in the air. Like let's say if I throw the ball like that, then you would have a V naught. Okay? But since we're just dropping it, you don't have any V naught. Does that make sense? Physics class and calculus later on in college, they're very similar. Okay? Okay, that's the lesson for today. We're done. Okay, hold on. I don't want you to leave yet, or I don't want you to clean up. I want you to at least try one